Good afternoon, I'm on site here at Embedded World 2022 and joining me today is Robert Owen, who is the Principal Consultant of the Worldwide University Programme at Imagination Technology. So thank you very much for joining us today. To begin with, could you introduce yourself and the company, please?
Yeah. Well, Imagination Technology is a medium-sized company, well known for its GPUs. We design processors, principally graphics processors that find their way into many mobile phones and tablets, and also into data centers and automotive applications increasingly. It's a British-based company with branches all around the world.
Fantastic, thank you. So can you explain for us what the Imagination University Programme is? What does it involve? What's the focus?
The aim of the program is to enable teachers to use our stuff in their classes.
Okay.
And the challenge always is, how do you take new technology, package it in a way which teachers can pick up and use, that's affordable for them, understandable, something they can set up, and something that works when you've got a classroom of students. It sounds simple, but the kind of technology that's used in new designs, that's in design labs, is often very expensive. The tools around it are difficult to use, they're very specialized. So translating that into an undergraduate classroom, particularly for electronic engineering students and computer science students, that's the challenge. That's what I do. And to be honest, it wasn't a career I chose. I ended up in it by accident in the end of 1994 with Texas Instruments. I only agreed to do it for 8 months, ended up doing it for 17 years at TI. And then since then, been to RS Components, Imagination, ARM, did some work for Xilinx, Enocean, various companies. And it's become a specialization. But the last 10 years, I've been at Imagination. And to be honest, it's been a thrill because they didn't have a university program. And they basically said, can you help us set one up? So I had to start with absolutely nothing and build up to what we have today.
Fantastic. Well, following on from that, sort of when you were designing the course, what key considerations did you have to think about?
There are 4 key factors. If you want to help a teacher, there's 4 things you must do. First of all, there needs to be a suitable hardware platform. Now that might be a computer, which is easy, but in many cases it needs a hardware board of some sort with silicon on it. That's often a challenge because the kind of things that are used for development are not the things that are friendly to a classroom. So the right hardware, you need the right software. And that needs to be free of charge and widely available. And a huge number of companies make a big mistake that they may put restrictions on the software, time restrictions, code size restrictions. Sometimes they try and charge for it. And if you're a teacher, licensing software for 100 students is a real pain. So easily available. And of course, with remote working, a lot of students now want to have that software on their own computer. So the right hardware, free software. Good support, that's usually a forum these days. But if you're using a forum to support people, there needs to be quick answers. We try very hard to get a solution to any teacher who's got a problem with our materials within 48 hours.
Fantastic.
And then the final part is the teaching materials. And the unique thing about the Imagination program, and this is really my signature, is that I find the best teachers wherever they are in the world, and I commission them. I pay them, put them under contract to write the best teaching materials on that subject. And then we publish them and make them free of charge, available to teachers, trainers. As long as it's non-profit use, anyone can have access to those materials. And it takes at least a year to develop those materials. They're usually would run for about 12 weeks in a course. There's presentation, lecture slides, there's a student manual, then there are proven laboratories. So when you've got the classroom of students and you're a teacher, and you say, right, I want you to start this software, download this program, modify this. It needs to be well tested so that it works and the students get the right learning knowledge out of it. And so a typical package of teaching materials is a semester long in terms of academic usage.
Fantastic. So there's a lot of time and effort that goes into it.
It's a big effort getting that ready. But, once the materials are ready, you then have the opportunity to take them out to teachers. And here at Embedded World, it's been wonderful to meet teachers and talk about, and you can see the excitement in their eyes as they rose. And there was a teacher yesterday from Poland. He said to me, Robert, this is fantastic. Really like the sound of this. He said, what's the catch? And I said, what do you mean? He said, well, how much is it? And I said, if you're a bona fide teacher, they're free of charge. He said, really? I said, yes, absolutely. If you use our materials, you're using our technology in the classroom, in the long run, they will be better qualified graduates. They'll know about imagination and they know about our technologies. So that's why we're making this investment.
Yeah, it's going to benefit everybody, isn't it?
Exactly.
So how do you work with partners to provide sort of the training, hardware and software?
When you're an IP company, your product, it's like a blueprint. You know, if you're an architect of a house, when you design a house, on its own, there's nothing you can use with that. You need a builder and materials. So partners are vitally important to IP companies. You know, when I was at TI, we thought we could do everything ourselves. And I didn't work much with partners at TI. I had to learn the hard way that partners are vitally important. And so for each one of our teaching courses, we've partnered with not only appropriate academics for the development, but with the right commercial companies to help us. And you know, if we take the RIS5 course, we've partnered with Digi-key. Digi-key have helped us to provide platforms, the hardware that we need. They're helping us to run workshops, to train teachers how to give the course. They're helping us promote the events and get the word out. Because, you know, as a medium-sized company, we look at Digi-key and go, wow, you know, you do one post on social media. And for example, we did a webinar about RVFPGA presented by one of the co-authors, Professor Harris from UNLV. And the Digi-key webinar was 2,000 people registered. I think we've had subsequently, you know, with Watch Again, something like 3,000 views.
That's incredible.
Now, that's partnership. You know, Imagination couldn't do that on their own, and I look at Digi-key and go, wow, you know, how cool it is to be working with you.
Yeah, definitely, fantastic. So as part of the programme, as you've mentioned, you've got a full suite of teaching materials and support. So can you go over again what exactly that involves?
There's 3 pillars of those teaching materials, and really they match with Imagination's commercial activities. So it's back to that, you know, the future designers. There is a good commercial reason to do what we do. We've got a set of materials around graphics. You know, we interact with graphics every day. But how does mobile graphics work? You know, on a phone, how do you create a picture? How do you move things about? How do you do that with great efficiency and low power? We have a course all about mobile graphics called Introduction to Mobile Graphics, and it'll even run on a Beagle board, which is a $50 platform. You can buy a BeagleBone Black from Digi-key. And that's a piece of hardware actually that Digi-key were instrumental in bringing to market. So there's a classic example of good partnership. So we've got a course around graphics, which is our core business. We are just about to release a course on Edge AI. So this is AI embedded in things, not data center, but the kind of thing that will be in sensors and intelligent IoT devices. And this is a really basic course. It's aimed at undergraduates. It's a start here. You know, you want to know what AI is and Edge AI and what are the most popular algorithms. That's what that course is around. That runs on a brand new Beagle board that was only announced last week called the BeagleBone AI 64. Again, something that Digi-key have been involved in. You can tell we love the Beagle stuff. It really helps us. So that's 2 of the courses. That AI one, end of September, that's coming out. I'm really excited because the new boards arrived this very morning, so the developers can finish off the course. The third element has been around computer architecture and SoC. And this has been a huge project. The generic name is RVFPGA. It's based on RIS5. Why RIS5? Because this is the processor technology that is sweeping everything. It's pervading every level of computing, from the very lowest level to the most elaborate supercomputer. Why? Because it's spurring innovation. It's exactly the kind of thing that teachers should be teaching today. So Imagination took the initiative very early. December 2019, we decided to do this, and by the end of 2020, we'd produced the first set of materials all around understanding computer architecture, but doing it on a RIS5 platform. So in this case, we used a Swerve core, which is a core that's open source. It's available for everybody to use. Imagination has used it inside some of its GPUs. We took that core from Western Digital, We put it onto a Digilent FPGA platform with a Xilinx FPGA on it, and we partnered it with Platform.io, another free of charge, widely available software development platform, an IDE. And those materials came out end of 2020. They've been hugely popular. We've now doubled the size of them. There's enough material for 2 semesters. What will the students learn? They start with the basics. What is the construction of a computer system? The processor unit, memory, I/O. How do they work? Look at some of those elements, then put a program in, get it running, sort of hello world type activity. And then the second semester of materials goes much more deeply. Like, what's a processor pipeline? How does it work? Why do you have a pipeline? How do you optimize parts of the processor for best performance, lowest power? How does the I/O work? Memory, what are the issues around memory? So it takes you quite deeply into the operation of the core. And this course is of the highest quality. We have a number of authors. Sarah Harris, who's co-author of a very famous book called Digital Design and Computer Architecture. It's probably the second most popular book on computer architecture after the Bible by Patterson and Hennessy. So it's a very popular book. She's one of the authors. The second author is in Madrid. His name is Daniel Chava Martinez. These are 2 teachers who are passionate about teaching, who really know about computer architecture and are used to using FPGA platforms as a way of emulating the environment that students can use to understand. And we have a 3rd semester's worth of materials called RV FPGA SoC, which follow the flow. They say, okay, you understand this processor now. Why don't we build a virtual SoC on the FPGA? Let's actually make your own system on chip. And then put an operating system, in this case Zephyr RTOS, onto that chip and run it and see what it can control. So that's more a master's level course. So there's enough material here to see students through their bachelor's degree and into their master's on that one platform. And of course, those FPGA platforms are already in a lot of universities. So for many universities, I've already got that hardware. That's the expensive bit. I can get the materials, the software's free, so it's relatively easy to put together what they need to teach their students. The challenge then is for the teachers to think, okay, how am I going to alter the old course and put the new one in and get used to the new environment?
Well, following on from some of those points you've just made, the current academic materials that are available contain a wealth of information, but seem to lack the vital start here materials that you mentioned, which is the foundation needed by teachers to bring the fundamentals of computer architecture to life. So why do you think it's important for students to be taught real-world examples?
Wow, that's a great question. And it touches on something that is part of my philosophy. Some of our competitors use a simplified core, an education core. I'll be honest with you, I think our teachers and our students are too busy to spend time on what, in my opinion, are toys. They're educational, but they're not the real world. This Swerve core is in silicon. It's inside Western Digital drives. It's inside Imagination GPUs. And lots of other customers are using it. It's got real credibility. And so that means it's harder to get started, but the benefit of making that effort is that then the students leave with real world skills. When they go into their first job, and their boss says, okay, what do you know about processor design? What processors have you worked with? If they say, well, we did computer architecture and we evaluated the Swerve core, the boss is going to go, okay, wow, that's helpful. So we've really helped the students to make them more employable and to be able to make a faster start in their job. So to make that startup easier, there's 2 things we do. The first thing is that the course includes a very comprehensive Getting Started guide, which is primarily for the teachers. And it covers lots of aspects like how do you set up the hardware, how do you set up the different elements of software, and because it's an FPGA, you've got software tools like Xilinx Vivado, as well as a programming environment for the processor that you're going to put onto the FPGA. So there's quite a lot of software to set up. And when you and I know this very well, when you're setting up new software, there's always this question, is that right? Is that okay?
Yeah.
You might get the odd error message and you're not sure what it means.
Yeah.
And you're thinking, is this right? Is it going to work? And when you start it working, you're still not sure. You don't know what success looks like.
Yeah.
So the Getting Started guide goes to a lot of trouble to help the teachers really understand what they're doing. So when they put it in front of the students, they'll be able to say, no, you shouldn't do that. You need to do this. You need to set that.
Yeah.
So that's we take a lot of time and trouble over that, so we can empower the teachers to have the confidence to introduce this to their students. And the labs then have been very, very rigorously tested to try and make sure that the students aren't going to find unexpected bugs that we didn't see. And then, in addition to that Getting Started guide, we have a program of what we call one-day workshops. And the philosophy behind this is, when we say to the teacher, come and give us a day of your time. Join us for a day. You'll meet fellow teachers who are doing exactly the same thing. Yeah. That's a good network to know. Yeah. But we'll help you through the setup. You can use your laptop, so the software gets configured on your machine. You'll work with real hardware. We'll talk about how you would set about putting this course into your curriculum, because every university has rules about how new courses are introduced. Yeah. And then we'll help you do a couple of the labs. So you'll get some confidence in running the system and how the labs work. Yeah. And at the end of the day, you leave with a new network. You'll have met one of the authors. Mm-hmm. We'll also publish this material online so you can watch it later. Mm-hmm. We are doing things like self-study for individual students, but most of our effort goes into training the teachers so the teachers can train the students. That way we can reach hundreds of thousands of students around the world.
Definitely, yeah, it sounds fantastic. So can you tell us about the Imagination RV FPGA Understanding Computer Architecture course? How is it giving engineering undergrads real-world skills?
Because they're understanding what a modern processor is. They're learning about the RISC-V instruction set. Yeah. And they're learning real-world tools, in this case, Xilinx Vivado for an FPGA, which is a very useful skill to have. And they're also learning a programming environment, in this case, Platform IO. Yeah. And in the near future, we will add support also for Catapult SDK, which is Imagination's own development environment.
Okay, excellent. So following on from that, why did Imagination make its first RISC-V product a product for education?
Yeah, that's a great question. I've been doing this nearly 30 years, and usually the university program comes last. So the company develops a product, then it becomes a chip, then it may finally get onto a board, and then the university program can pick it up and work with it. So we normally come last. It was incredibly exciting at the end of 2019 when Imagination said, look, Robert, we may move into RISC-V. And what we'd like to do is to be seen as being part of the community. Yeah. If we funded you, would you like to take a project you did in the past, which was called MIPS FPGA, take that concept, update it, make it around RISC-V, and that'll put us at the center of this new community? Well, I didn't need any time to make out. It's the best opportunity I'd ever been presented with. Yeah. So I enjoyed spending some money. I was able to go back to some of the greatest authors. Honestly, the teachers I work with, you couldn't wish for a better team. They are wonderful people, and their enthusiasm is what keeps me going. Yeah. And they've produced beautiful materials. And when you see the teachers, oh, this is really good. I can use this. And the way we present the materials, it's academic in style. These are not commercial or marketing materials. Yeah. The primary aim is education. It's not about advertising Imagination or its products. So Imagination found itself very much active inside RISC-V. We were end of 2021, we won a community support award from the RISC-V International Group, which was much appreciated. Yeah. And as the people inside Imagination who'd started to develop our first RISC-V processor, as they discovered when they came to the summit, lots of people already knew about us and our activities. So it worked. Yeah. But it was the first time the university program had been the first product.
Yeah, and I love the fact that it's the community that's the focus. You know, that's such a big part, isn't it?
And that's essential. You know, I've had quite a few of, let's say, the traditional vendors in this area puzzled about what's going on in RISC-V. And what I would say to them, get involved, join the organization, go to some of the meetings, and then you realize, first of all, how big it is.
Yeah.
I mean, the army of people around the world that are involved, the range of projects, and the way RISC-V is structured facilitates innovation. So if somebody has a bright idea and say, well, if I could have a set of instructions that could do this, this, and this, I could make that application run faster, use less power, and be more silicon efficient. That's what RISC-V has empowered. You know, the stuff about that it's royalty free and a lot of it is open source. In a way, that's incidental.
Yeah.
It's the customization by anyone who wants to. Anyone can form a team and start to create something new. That's what's exciting about it.
Excellent. So I understand you've also teamed up with Digi-key to write the guide to RISC-V. So can you tell us more about that?
Yeah. An author I worked with when I was at TI was coming up to retirement, and he invited me to his retirement party and said, you know, Robert, I'll have more time if you need any teaching materials checked or written. And after this retirement dinner, I was driving home and I thought, I know, because YC Wang, a big thank you to YC at Digi-key, who's given us a lot of help. He'd mentioned to me you were producing e-guides as part of your academic program. And I thought, I wonder if he's got one to RISC-V, because it's back to this, you know, well, what's the fuss all about?
Yeah.
And so I said to him, look, I think I found an author. I said, how about if Imagination funds and guides it and we jointly publish it? So the Digi-key and Imagination Guide to RISC-V is available free of charge on both websites.
Yeah.
And it's a great place to start because, first of all, it covers what's special about RISC-V and why it's different.
Yeah.
And it then looks at 3 implementations. It looks at the RV FPGA using a soft core, the Swerve. But it also looks at a microcontroller implementation, in this case a Sci-Fi device.
Yeah.
And it looks at a microprocessor implementation, which is, I'm trying to remember, it's a SiPi board. I think it's a Kendrite processor.
Okay. Yeah.
And so it gives you 3 examples of RISC-V being used in practice. It's about 50 pages. And you know, if anyone's watching this and thinking, what, more fuss about RISC-V, you know, read this guide. You know, you'll be an expert then.
Yes,
and you'll
fantastic.
probably be wanting to get involved.
Yeah, definitely. And I mean, following on from that, can you tell us also about the workshops that you're running with Digi-key as well?
And Digi-key have helped us promote it, so big thank you, because we can't do that on our own. In the US, they also provided the boards, which was very helpful, because there was some hardware costs there. We've had the first event in the US, which was in Las Vegas in May at UNLV, which is the home of Sarah Harris, the co-author. Yeah. We're going to be at MIT in Boston on the 9th of September.
Okay.
And then we'll have an event coinciding with the RISC-V Summit. So in Silicon Valley, we'll be at UCSC Extension, which is just down the road from the San Jose Convention Center, and that's on 15th of December. Okay. And the RISC-V Summit, the conference is on 13th, 14th, and then 15th is workshop days. And my aim is, with Digi-key's help, this will be the most popular workshop in the US at that event. Yeah. And then in Europe, 5th of July, we're at Imperial College in London, and Daniel Chava Martinez, the other co-author, is the host there. Yeah. We're then at the Fachhochschule, University of Applied Sciences in Munich, hosted by Stefan Walentowitz, who's a well-known RISC-V guru in Germany. That is on the 7th of September in central Munich. Mm-hmm. And then on the 20th of September, there's a conference on the 21st of September in Spain called Sarteco, S-A-R-T-E-C-O. The day before the Sarteco conference, University of Alicante are hosting an RV FPGA workshop, and Daniel Chava Martinez is the trainer there. So 6 locations in the US and Europe, and we have a huge program of workshops planned in China, which are on hold at the moment for reasons we all know. Yeah. And towards the end of this year, early next year, we'll be in Tokyo, Taiwan, and Korea with the workshops as well.
fantastic. So many great opportunities for people to come along and get involved.
And it's that, you're a teacher,
Yeah.
you're looking at this and thinking, maybe I should update my course, but it's a lot of work. Give us a day of your time and we'll really shorten that. We'll make it easy for you to get started.
Yeah, it'd be worthwhile. Now, I understand Imagination has also recently introduced the IMG RTXM 2200, which is its first commercial licensable IP from the RISC-V based Catapult family. Can you tell us a little bit more about that?
Yes. Interesting, we've been in the community now for 18 months with teaching materials. Now we've entered the market for IP. Obviously, Imagination is well known for being able to design power efficient, highly verified, reliable designs.
Yeah.
And this is our first RISC-V processor designed from the bottom up by Imagination. Yeah. And that set the framework and the foundations for what will be a long-term project. There'll be multiple designs coming in the future. Yeah. We've been assembling the team to do it. That's why we've been recruiting so strongly. And this device is, it's mid-range. It's got certain characteristics, particularly in power consumption and efficiency, and the fact that customers know that they'll get the very best support if they decide to include that. And so this is where I think there's a lot of confusion about RISC-V, is that people think, someone does a design, they throw it out there and anyone can pick it up, but there's not really any support other than the community. That's not the case. You can have open source cores which are community only support, but companies can also do their own dedicated proprietary implementations. They can use RISC-V, they can adapt it the way they want, and they can come up with their unique implementations and then support it just like IP has been done in the past. Yeah. And to be honest, that's the strength of Imagination. It's the design, the efficiency of the implementation, the tiny silicon area that we'll get, and the power efficiency, and the support that we will put around it.
Yeah.
And that's the primary reason why somebody who's got a very critical design would say, well, actually, if I choose Imagination, that's a really safe choice. If I want to go RISC-V, there's a company I can trust to do it properly. Yeah,
brilliant. So what sort of applications can you see this new product being integrated into?
Embedded control. Yeah. Supervisory processors in larger systems. And I think in the longer term, it will lead us in the automotive direction as one of the application areas. Things that are safety critical. Again, there are approvals required, certifications required for automotive, and that's something that Imagination's had long experience of because of its GPUs. Yeah. And we'll be able to bring that expertise to our CPUs as well. Yeah. But this is a marathon, not a sprint. Yes. But you can imagine, I feel quite good that the university program now is not the only product, but we're now, we're in the commercial field with RISC-V as well.
Brilliant. Well, thank you so much for your insights today. It's been a real pleasure speaking with you, and I look forward to seeing where the program goes in the future. So.
Thank you very much.
No,
Paige.
thank you.
It's
Enjoy the rest of the show.
I'm enjoying it immensely.
Thank you very much.
Thank you very much.